Good evening, dear students. In yesterday class, we discussed the efficiency of heat engine and another the criteria for the spontaneity. The criteria for the spontaneity is eta is equals to W by Q. Here, the heat engine can convert all the heat from the high temperature reservoir into the work. Such an engine would be 100% efficient. So this is a criteria for the spontaneity of a heat engine, the efficiency of the heat engine. Okay, in today's class, I am going to discuss about and already discussed the Gibbs free energy, and today's class I am going to discuss about the variation of free energy. The variation of free energy, which is temperature and temperature. The temperature and pressure. The unit name is Thermodynamics-II. Here, the variation of energy, the variation of free energy, that gives free energy, the variation of free energy, the variation of free energy with the variation of free energy with the temperature and pressure, with the temperature and pressure, the temperature and pressure. This is the variation of free energy with the temperature and pressure. Here, the varying the pressure and temperature. Okay, here the variation of temperature here according to the definition of the Gibbs free energy. According to the definition of Gibbs energy, here that this is a derivation is there. Here according to, you consider according to definition of that free energy. Here you get the equation is G is equals to H minus TH. G is equals to H minus TS. Okay. Afterwards, you know the enthalpy here. H is equals to, take this side, H is equals to, that is G E plus P. E plus P into, get the E plus PV, and you add this H value in this equation. And here I am adding this H value in this equation. That is G is equals to, here H means E plus PV minus TS. H plus PV minus TS. This is the equation number 1. Okay, this is the equation number 1. And differentiating this equation, you differentiate this equation number 1. Differentiate the equation 1. We get equation number 1. And we get the differentiate here, dz is equals to dE plus, here the differentiation of second function, this, the differentiation of first function is constant and second function is differentiate, and second is the differentiation of second function here, the differentiation of first function, and this is constant the second function. Here according to differential equation, here P into dV This is the first function. Differentiation of second function plus here the differentiation of this first function here v into d. You see here this is that dz is equals to that dz means differential of dz is equals to d differentiation of de plus p into d. Here you kept the first function, second function differential plus second function and first function is differential p dv plus v dv and here this minus here also same first function differentiate second function ds minus second function differentiate first function. Yes, okay. Minus t ds minus s dt and this is the equation number 2. This is known as equation number 2. Next here, no, for the infinite decimal here, we consider the infinite decimal of the reversible process we have, that is dq is equals to the d plus dw, d plus dw and the ds take according to this, that is a ds is equals to dq by the differential function, that is this is a entropy. Here the ds is equals to dq by t and if the work done is expected to the work of expansion, then we get that is dq is equals to the d plus dq is equals to d plus p dv and ds, this one ds is equals to the d plus p dv divided by temperature, that is a 2. You get divided by t, that is ds is equals to d plus p dv divided by t here. This is a ds is equals to dq by dt, t divided by dq is equals to d plus p dv according to the work done, that is dq is equals to d plus p dv. And in expansion, you know that ds is equals to d plus p dv divided by t here and substitute this value of ds, substitute this value of ds, this value of ds this value of ds. To substitute this value of ds and we get the equation number ds in equation 2. In equation 2 we get here we substitute these values in this equation. Here, see here, I am substituting the value of ds. dz is equals to the d plus pdv plus vdv minus t into ds. ds value is here d plus p dv divided by t. Here I write d plus p dv divided by t minus s dt. Okay, see here dz is equals to the dE plus P dV plus V dP minus of T into dE plus P dV divided by T minus of S into dt. Okay, this is a temperature and this is a temperature. This is a multiplication cancel. This one temperature and this one temperature. Here remaining dZ is equals to dE plus P dV plus V dP here minus dV minus into plus minus P dV minus of S dV. Okay, here minus of S dV. Here dE minus dV plus D minus dV. Okay, next plus dV minus dV. Remaining only this one VdP and minus S dt. You get this equation number, that is dG is equals to the VdP minus S dt. This is equation number 3. We have this get of equation number 3. And the pressure remains constant when in this equation the pressure remains constant, that is dG divided by d. So here the pressure remains constant, dG pressure constant is equals to minus S dt. Okay, this is a minus S dt. And but at constant temperature, here the pressure remains constant, it is 0. dC at pressure remains constant, it pressure is equals to remaining is only S dt. And here this is equation number 4. Okay, here we get the equation number 4. Afterwards, that is, but here the temperature is constant. Temperature is constant. Temperature is constant. That is dt is equals to 0. Substitute dt is equals to 0. That is dG temperature constant is equals to V dt. You get, that is dG temperature constant is equals to V dt. This is equation number 5. Okay, here the equation number 4 and 5 simplify equations 4 and 5 we get simplifying this equation number 4 and this equation number 5 we get, that is dG divided by one time dt. So one time this one dt and another time dt. And here dG divided by dt. This is dG divided by dt at constant pressure. At constant pressure, and this is equals to, here you get the constant pressure means remaining only dG divided by dt, constant pressure, here remaining is minus S. Minus S. You take this is a equation number 3. Okay. And next dG divided by dP at constant temperature, you take, that is this one dG divided by dP constant temperature, this is equals to here dG divided by dP, here dG divided by dP, temperature is constant, remaining is V, that is 1 here V, and you consider this is a equation B. You consider this is equation number B. Okay, this is equation number 1, equation number 2, equation number 3, and 4, 5, and this is equation number 8, and this is equation number. Okay. Afterwards, please continuation here. Okay. So equation A and B gives the equation number A and B gives the variation of free energy with respect to the temperature and pressure. That is the temperature and pressure. Here the equation I write here the equation A, this one, and equation number B gives the variation of free energy, the variation of free energy, the variation of free energy with respect to WRT. This is with respect to pressure and temperature. Pressure and temperature. Pressure and temperature. Free energy with respect to temperature and pressure. And here by the definition we have the equation is by definition. By definition, the equation we get the equation is definition of free energy. Here definition of free energy. Here the equation is G is equals to H minus Ts. G is equals to H minus Ts. G is equals to H minus Ts, and here G is equals to E plus PV minus Ts. E plus PV minus Ts. Because of H is E plus PV. You see already I written here. Here H is E plus PV, and here the H value is substituted in this equation, that is G is equals to H minus Ts, and finally we get G is equals to E plus PV minus Ts. Okay, here we get that is a dG is equals to dE plus PdV. Differential equation here dG is equals to dE plus PdV plus VdV. PdV plus VdP minus TdS minus SdT minus PdS, TdS minus SdT. Here this is the first law of thermodynamics, that is dE is equals to Q minus W. Get the final equation. This is which shows the variation. Equation A and B gives the variation of the free energy with respect to the pressure and temperature. Here this is this equation and this equation, these two equations gives the variation of free energy with respect to the pressure and temperature. Here the according to first law of here, this is a dG is equals to H minus Ts, G is equals to E plus PV minus Ts, and then you get the differential equation here. This is the first function is constant, differentiate second function, and then the second function is constant, and you write as it is first for second function and differentiate first function. And here this is finally get dG is equals to dE plus PdV plus VdP minus TdS minus SdT, and this is for the first law of thermodynamics, that is dE is equals to Q minus W. This is the variation of the free energy of temperature and pressure. Okay, next the Gibbs-Helmholtz equation. Gibbs-Helmholtz Gibbs-Helmholtz equation. So this is a very important for 5 to 6 months question. 6 months question. Here there are the expression for the Gibbs-Helmholtz equation. Here the Gibbs-Helmholtz equation, there are two equations is divided by Gibbs and Helmholtz. Sorry, here one is a Gibbs equation and another is the Helmholtz equation. These are divided two equations and give this is referred as the Gibbs-Helmholtz equation. This one equation, the divided equations are known also Gibbs-Helmholtz, are referred as a Gibbs-Helmholtz equation. And here the one can is expressed here in terms of the changes in the free energy, that is delta G. Here the free energy changes is delta G. And here changes is G2 to G1. And the enthalpy delta H, here this is free energy changes and delta H. The changes of two terms, one is of delta G and delta H, while the other equation can be expressed in terms of changes in the internal energy, that is delta G, and the work function, that is delta E. Work function is delta A and energy, that internal energy is delta G. And here we know that from the Helmholtz equation in terms of delta G and delta H. And here write from the equation number 3. In the last equation number 3 is VdP minus VdT. Sorry, VdP minus SdT. We know that from equation, okay, equation 3 is the dg is equals to the VdP plus, sorry, minus SdT, minus SdT. Okay, here this is equation number 6. From equation number 3 in last equation, at constant pressure, that is dP is equals to 0, that is dP is equals to 0. We'll write here. Here dg is equals to pdv minus sdt. Okay, and next the dp is equals to 0, dp is equals to 0 and dp is equals to 0. In the equation you get this is dg is equals to minus sdt. Okay, here you get dg, that is dg is equals to minus sdt. After, let us consider that is G1 be the initial free energy. This G1 is the initial free energy. Initial free energy at the temperature T1. At the temperature T1. At the temperature T1 and G1 plus dG1. You get a dG1. Temperature is T1 and G1 plus dG1 be the free energy at the temperature T1 plus dT. That is T1 plus dT1. And finally, this equation we get, that is dG1 to replace, that is here dG replace, that is dG1 is equals to here minus S dt. Here you get S1 dt minus S1 dt. This is equation number 1. And then that is, let us consider G2 is the final free energy, final state free energy at the temperature T2, and G2 plus dG2, and here T2 plus dT2. Here let replace at final state, at final state, at final state here G2 at free energy temperature T2, and you get G2 plus dG2 and substitute T2 plus dT2, and here you substitute this equation in this equation, and here dG2 is equals to the minus S2 dt. S2 dt here. This is the equation number 2. This is equation number 1 and this is equation number 2. And subtract this equation number 2 in equation number 1, that is 2 minus 1. This equation number 2 and this is equation number 1. Subtract equation number 2 minus in equation number 1. Okay, here the equation number 2 and equation number 1. Finally, we get here dG2 minus dG1 is equals to the here dG2 minus dG1. dG2 means minus S2 dt, and here G1 means minus S1 dt. Minus S2 dt minus S1 dt. Here you take dt's outside, that is S2 minus S1 minus S2 minus S1 dt. Okay, here you get, that is delta G, this change in energy, delta G is equals to S2 minus S1 means minus delta S into dt. Okay. So S2 minus S1 is a delta S into dt. And now at constant pressure, at constant pressure, at constant pressure, that is d delta G divided by this one d. Therefore, this is equals to the, that is constant pressure. Here we have taken constant temperature, sorry pressure. Here you write pressure d into delta G divided by dt. That constant pressure is equals to only remaining is minus delta S. Minus delta S. Here this is equation number 2 and this is equation number 3. Next, that we have the delta G is equals to, this equation, that delta G is equals to the delta H minus T delta S, minus T delta S, and you take the outside, minus delta S is equals to, minus delta S is equals to the this one delta G minus delta H divided by this one T. Delta G minus delta H divided by T. minus delta S is equals to delta G minus delta H divided by T. This is equation number 4. Equation number 4. And comparing the equation number 3 and equation number 4. Comparing equation 3 and 4. We get comparing equation number this 3, equation number 3rd and equation number 4. This one here the presence of minus delta S, here also presence of minus delta S, and here the delta G is equals to delta H minus T into delta S. We compare this equation and we get the equation that is delta G this one delta G is equals to delta H. This one delta G is equals to delta H minus here minus T D. This one minus T D, and here you substitute in delta S value D into minus delta G minus delta G divided by that is here dt at constant pressure. This is equation number 5. You get the equation number 5. Okay, here according to this equation number 5, according to delta G is equals to delta H minus T D into bracket D. This equation D delta G dt into pressure. Pressure is a constant. You taken this pressure is a constant. According to equation number 5 is referred as a Gibbs-Helmholtz. This equation is known as Gibbs-Helmholtz. That is Gibbs-Helmholtz equation in terms of the free energy and only in terms of the free energy. And the enthalpy change at constant pressure where delta G and delta H are variable. Here the delta G and delta H, these two terms are variable, and the Gibbs-Helmholtz equation in terms of this delta H and delta G is variables, and by the definition we get the it changes the work done, that is A is equals to this is known as this equation is a Gibbs-Helmholtz equation, not a variable. Here A is equals to, that is by the definition we have A is equals to E minus Ts. E minus Ts. This is from equation number 2 here. In last here this is a is equals to E minus T. Differentiate, that is changing variable delta A is equals to delta E minus that is T into delta T. Delta E is minus T into delta S. Finally, you get that is delta minus delta S. You take this side minus delta S minus delta S. Therefore, this is equals to taken outside here. This is a minus delta S that is equals to the delta E minus delta E divided by T. That is delta A minus delta E divided by T. And this is a equation number 6. This one is equation number 5 and this one is equation number. Next, continue this process. Here minus delta S is equals to delta A minus delta E by T. Here this is simplified. You written rearrange this equation, that is delta A is equals to delta E minus T into delta S. here. Afterwards, minus delta S is equals to delta A minus delta E divided by T. Then you consider the minus delta A, that is differentiating equation, that is differentiated equation. This one, differentiate this equation, you consider that is a x. Differentiate that equation x, and the differentiated equation is finally come minus delta A is equals to minus delta A is equals to the delta E, that is, or you take delta S, that is delta E, delta A plus delta E divided by T. And finally we get the differentiated above equation, and write the differentiated equation, this one, this is the differentiated is dA. dA is equals to this dE, this is equals to dE, and then minus Ts, minus T into ds minus S into dt. Okay, differentiated here second function, and here differentiated is second function, and here differentiated is first function. And then you get this is the equation number 6, and this is equation number 7. Okay, this is the equation number 7. Next, dq is equals to dq is equals to that is dE plus PD. dE plus PD according to the definition. dq is equals to dE plus PdV, and you take dq is equals to dE at constant pressure. dq is equals to dE. Okay, here the constant volume, that is called, here the constant volume, that is dV is equals to 0. Constant volume, here the dq is equals to dE. Here the dV is equals to 0. Substitute 0 is in this equation, and if any of the multiply 0 is a 0. Here the dq is equals to dE. Finally, get this. And for the reversible process, entropy change, that is ds is equals to Q reversible divided by temperature. Now here Q reversible, you consider dq is equals to that is ds into or t into ds. Okay, finally that is put the value, that is dq is equals to t into ds. We get dE is equals to t into ds. dE is equals to t into ds. dE is equals to t into ds. And then finally you get, so here t ds is equals to d. No problem. D is equals to ts, and t ds equals to d. And next dq is equals to t ds means d here. That is t ds minus d. And next, this is equation number 8. You get this is a equation number 8. And next, now comparing equation number 8. Comparing equation number this 7 and 8. Comparing equation number 7 and 8, we get equation number 7 and 8. We get the dA is equals to the dE minus S dt. dE minus S dt minus t ds. dE minus S dt minus t ds. Same here as dt minus so t ds. d ds. For comparing, that is equation number 7 and equation number 8. That is finally you get dA is equals to take also dE minus S dt and minus t into ds minus of ds here minus of d sorry t ds minus t ds minus of d minus of therefore minus of s dt minus of s dt. Next, it finally becomes dA minus TdS minus d. TdS minus d is a dt. See here, this equation minus ds minus d. TdS minus d that is dt. dA is equals to the minus dq minus of s dt. Minus of s dt. Therefore, at dq is equals to 0 minus dq, this dq is equals to 0, we get dA is equals to minus s into dt. Here, dA that is work done here. dA is equals to minus s into dt. And so here the a1 where is that is a1 to a2 and the work function of the at its initial and final state or final stage at the temperature T and A1 plus dA1. This is the initial state and A2 plus dA2. This is a final state. A1 is the initial state and A2 is the final state. At the temperature is D plus dt. And here we get, see here, this is a A1 plus dA1 and A2 plus dA2 and T temperature T plus dt according to this equation. And according to this equation, here we get dA is equals to minus s into dt. And next the equation we have here continuation for this. For according to this equation, dA is equals to minus s dt. dA is equals to minus s dt, and here we take dA1 is equals to minus s1 dt minus s1 dt. This is equation number. You consider A and dA2 is equals to minus s2 dt. This is d. You consider this is a d and you subtract this a and b. Subtract this a, sorry, this b minus a. Equation number b and equation number b. You subtract these two equations and you get dA2 this one minus dA1. Therefore, this is equals to minus of s2 minus s1 dt. And then, so at constant value taken here at constant value V and D into delta A. You get this one D into delta A. That is delta A is a change in A2 to A1, A2 minus A1 D D is taken outside. A2 minus A1 change in that was done here delta E. Therefore, this is equals to the this S2 minus S1 means delta S. Here minus of delta S into dt minus delta S into dt. This is equation number 9. This is equation number 8 and instead of equation number 9 at constant y. Equation number is at constant y. And finally d into delta A, this one d into delta A divided by dt. You take this side here, d into delta A divided by dt at constant volume. Therefore, this is equals to remaining is equals to minus delta S. Is equals to minus delta S. This is equation number 10. So this is equation number 10, and you know that is delta S is equals to the delta A minus delta S divided by temperature T. This is from equation number that is equation number 6 here. From equation number 6. From equation number 6 and 10. Compare here the equation number 6 and 10. You get the d by dt is equals to, that is, sorry, this is comparing these equations, that is equation 6 and 10. You get the equation is t by dt into delta A is equals to, that is volume is constant, here is equals to delta A, so this is D, and delta A minus of delta E divided by temperature T. And here this equation is rearrange the above equation, and then finally you get delta A is equals to the delta E is equals to the delta E is equals to the delta E plus T, this one T, this is a T. Delta A is equals to delta E plus this one T into this D, delta A divided by D, delta A divided by D. Okay, this is the equation number 11. You get the equation number 11 here. Only rearranged delta A is equals to the negative delta A is positive delta E plus T, this one T, and delta A divided by dt, differential of delta A by dt. Okay, here the volume is constant. We are comparing the equation number 6 and 10, and you get this equation and rearrange this equation, you get this equation number 11. You get the equation number 11, and this final they gives Helmholtz equation in terms of the internal energy, that is internal energy delta E. Delta E is or delta U. You take on delta E or delta U. That is the work function is delta E. Okay, this is a equation for Gibbs Helmholtz equation, that is Internal energy delta E at work function is a delta. This is a very important for 5 to 6 marks question. Okay, I'll stop here and continue in next class. In next class, I'll discuss the Clausius-Clapeyron equation, the derivation of Clausius-Clapeyron equation. Thank you.